Hello, my name is Sigurdur Helgason and this is a portfolio submission for procedural animation. In this video, I'm going to show how to make a river flow shader in Unity using Unity's shader graph. Shader graph is a node-based system which allows the developers to create custom shaders in a user-friendly way without having to write code. The process of making a shader in shader graph involves creating nodes on a workspace and then connecting them together to achieve the results you're after. When you have connected the required nodes, you will then connect them to the master node that is determined by the render pipeline being used. To use shader graph, you will need to be using a scriptable render pipeline, namely the universal render pipeline or the high definition render pipeline. In this tutorial, I will be using the universal render pipeline. In this tutorial, I will show how I made the river flow shader from a VR roguelite shooter with the working name The Heart of the River. The game involves having the player going down a river on a boat while shooting enemies along the way. The entire game takes place on a river and therefore it is an important visual element of my game. The game has a low poly art style and therefore a river flow simulation will also have a low poly look to it for visual fidelity. However, this technique can be used for a variety of art styles. There are a few things we need before we go into shader graph. First of all, is a texture and a normal map that we will be moving along the river. Next of all, we're going to need a river model. In my case, I split it into a few sections to be able to control the speed and the flow of the river better. And then we need a flow map that I'm doing here in the software flow map painter. I use the UV maps as an overlay to be able to control the flow better and see it. And as you can see in the software, in the flow map, the yellow line here that I made, that it is yellow because it is moving towards the upper parts or yellow-green parts of the UV coordinates because it's the UV coordinates that we use to move the texture along the river. The reason that the rest of the flow map has this pukish green color to it is because that in the flow map 0.5 red means zero movement along the x-axis and 0.5 green means zero movement along the y-axis. Now when we're in Unity, we can see here we have the normal map, the texture, the flow map, and the segment of the river I'm using. To make a shader, we go to Create, Shader, Universal Shader Graph, and make a lit shader graph. And we call it River Flow, and then we double click it, and then we are in the shader graph. Now, the first node we make is a sample texture 2D node. That's where the flow map will go. Then we'll make a property, call it flow map. That will enable us to add the flow map in the Unity editor. Then next we will make a split node. That is because we only need the red and green channels of the flow map. That are the only colors that have the information that we need. And we put that in a combine node to combine the channels. And next we're gonna have to make a remap node. That is because we are using the flow map to affect the UV coordinates of the texture we're using to stretch it in a direction. And the flow map uses the value 0 to 1, where 0.5 is no motion. However, we are going to have to be using the values -1, which is negative motion, to 1, which is positive motion along an axis, where 0 will be the no motion. So we need to remap those values from 0 to 1 to -1 to 1. Next, we make a multiply node, connect the output of the remap into that one, and then we make a property that we call strength. That is going to be the flow strength of the river. It is useful to be able to customize it on the go. Next, we are going to make an add node. We will connect the multiply node into the add node. Then we're going to need the tiling and offset node. This will add the UV coordinates of the model we're using. And also we are going to add a tiling property for the texture. And this is going to enable us to tile the texture in the Unity editor, which is very, very useful. Next, we are going to make another sample to texture 2D, and this is going to contain the actual river texture that we will be moving. We will connect the flow map branch into the UV input of the texture node, and then we will make another property, river texture. This is so we can add the textures in the UV Unity editor, and then we connect that to the base color, save it, and take a look at it. We create a material in Unity, call it river flow. We will set the shader, go to shader graph, river flow, add the flow map, and add the texture, put the strength and tiling to 1 so we have some effect. And then if we add it to the plane here for better visual, we can show that the texture is being distorted in the direction that the flow map says. Now next, we are going to move the texture. We do that by increasing the values of the flow map from 0 to 1. This will gradually move the texture in the direction of the UV coordinates as directed by the flow map. To do that, we make a time node, connect that to a multiply node, and then we make a speed property so we can control the speed in the Unity editor. Next, we are going to make a fraction node. The point of the fraction node is that it only counts decimal numbers, so it counts from 0 to 1 repeatedly. Now if we take the flow maps and we disconnect them for a while because we're going to add a multiply node. Now we connect the flow map into one of the inputs of the multiply node and then connect it back into the texture, and then we connect the time node into the flow map, and now we can see that it moves, but it resets, so the movement looks jagged. Now, how we fix that is that we make another branch of texture to be moved. So they will be moving on top of each other, but the new branch will have an offset. So it will move into each other and reduce the jagged movement. So we do that by first going to the multiply node connected to the time. We make a 0.5 offset. Then we connect it to the fraction node. Then we connect to a multiply node. Then we take another output from the flow map and we connect to that to the multiply node. And then, because we are of course using the same texture again, just on top of the other with an offset, so we can copy all of this, put it there, and move it a little bit here, and then connect the new output of the flow map with the offset to the texture. Now we have the texture of the river being moved twice, but one instance of it with an offset. So they will move into each other and the reset of the texture will not be as noticeable. But to have a smoother movement, we're going to have to add lerp, or a linear interpolation node. We connect one of the flow branches into the A input and one to the B input, but then we need a T input to interpolate between those. Now we do that by going back to where the time nodes are. And we will make another fraction node. We will connect the output of the multiply node from the time node to the fraction node, and then to a remap node similar than before. Connect that to the input and change the values from 0 to 1 to -1 to 1. Then we make an absolute node and connect that to the remap node, and that makes sure that the interpolation values go from 0 to 1 and then 1 to 0. So it makes like a ping pong interpolation between the A and B values from the flowing textures and the offset texture. So here we can see how it looks with the interpolation and the two textures. It makes a pretty good flow. But that is not all. What we have been doing is actually making a subgraph. So we select everything we've done so far, make a subgraph. We call that the river flow subgraph. Now we can see everything is in a single node that is connected to the albedo of the master node, but we still need a normal map. So what we do is we create a node that is a subgraph that we just made, river flow subgraph. We use much of the same values as from the first subgraph. We use everything except for the texture properties, because in the texture properties of the new subgraph we will connect a normal map property, so we can add the normal maps in the Unity editor. Now we just have to make a new node, normal unpack node. We connect the normal flow map to the normal unpack to designate the normal texture as a normal map. Then we take the output of that and put it into normal strength. Then we make a property so we can control it in the Unity editor, which is sometimes useful. And then we take the output of the normal strength and put it in the normal tangent of the master node of the river shader, and then we're done. We add the normal strength and the normal map. If we play with it a little bit, change the tiling, it depends on what purpose you're using the flow map. If you increase the strength a little bit, the flow gets a bit stronger and more continuous. The normal strength was a little high, we can change that. And so, that's it. Now, one of the classic issues you can have is that you make the flow map shader and it looks like this. The flow map that you drew is all out of whack, and the areas of the object are moving that are not supposed to. So what is happening is that when you import the flow map, you need to detag the sRGB of the texture. That is because it's not a color texture, it's actually just the numbers that we are applying to the UV coordinates. And then you go to compression also, and you put it to none, which makes the flow map look a little bit better. And that's how we make a river flow shader in Unity using shader graph. Thank you for watching.